So usually how I like to start these conversations is really about an individual's journey. And when I speak to them, they're working on something pretty fascinating and it's going to be part of their life for a while. I just kind of want to take the quick roadmap of how you went sort of from a mechanical engineer by trade in college to becoming a co-founder of a sustainable diamond company.
My path to get here hasn't really been a straight shot. It's actually bounced left and right a few times. And I came out of school in the height of the recession. There was a significant portion of my graduating class that didn't have jobs. I had been working in New York City over summers, interning for a company that did high-end cabinetry and furniture, custom stuff for really high-end clientele, and was able to parlay that into an entry-level job working for a company that made high-end architectural home hardware. So architectural home hardware is a really fancy way of saying expensive custom doorknobs. I worked for a company
Nice.
that made really custom doorknobs and hinges and finials and lock sets for some of the world's elite. Clientele included Madonna, Jay-Z, Michael Bloomberg. So I got exposure to that really early, and really, that was the base for my career, understanding how to build and develop luxury products, for a discerning client. And I was only at the company for a couple of months when the owner approached me. He had seen a video that I'd published on YouTube of an electric motorcycle that I'd built at home, and I think at the time it had over 100,000 views. And he said, "Oh, so you're pretty good with your hands. We've actually been looking for someone internal that we could tap to build out our metal foundry." And at the time, they were doing some small format investment casting, and this is actually the same method that's used to cast metal for jewelry. And they were doing that for some of their smaller pieces, and they wanted to expand their capabilities and basically bring things in house that were prior being outsourced. So I jumped at the opportunity, and here I was only a few months out of school, and now I was tasked with essentially building out this manufacturing facility, building out our standard operating procedures, hiring and training the team. It was a huge jump up in responsibility and pay, and I was excited about it. And we got this large format metal casting operation off the ground, and things were going swimmingly. The challenge for me was it was a really far drive from where I was living to mid Long Island.
Mhm.
Probably like a 2-hour drive each way.
Oof.
And yeah, so that was tough to do for a long time, and it became more and more difficult as time continued, and I ended up leaving and finding a job that was tangentially related in the world of jewelry. So I started working for David Yurman, and obviously the prerequisite for understanding how to make jewelry is understanding a little bit about metal casting, and obviously I had relevant experience in that, dealing with small metal componentry. A lot of the stuff that we did with respect to the architectural home hardware actually had small mechanics involved, whether that be like set screws, different elements to help assemble the pieces. So a lot of it actually tied very closely to how jewelry was manufactured. And I found myself working for David Yurman on like day 3 or 4 of my employment at David Yurman. I ended up meeting one of the guys who's higher up, who was running their new men's team. We were, I think, parking our motorcycles outside of the office, and we get to talking. He's like, "Oh, who are you? You're new here, yada, yada, yada." Next thing I know, I'm the newest member of the men's jewelry team. And we had a really wonderful experience over the next few years growing this men's line, which really succeeded in integrating non-traditional materials and bringing them into the world of jewelry. Things like Gibeon meteorite. You see it all over now.
Right.
That was not the case 10 years ago. So the Gibeon meteorite was a meteorite that broke up over Africa several thousand years ago, and it has this really cool internal crystalline lattice structure. So if you cut the stone and you acid etch it, it reveals that pattern that is otherworldly, and that would make sense because it doesn't come from this planet. And it's a beautiful material. It's hard to make into fine jewelry because it's ferrous and it will rust. So you have to use chemistry and material science to essentially unlock that material and utilize it in these luxury products in a way that satisfies consumer expectations. So worked on that, sat in between design and large-scale manufacturing, and developed collections that heavily relied on these non-traditional materials, and then I ended up leaving the industry. I founded a direct-to-consumer connected safety products company for the motorcycle market, and left the world of jewelry in my rearview mirror and focused on that. I built that company up. We scaled our product to a consumer footprint in 130 plus countries around the world over the course of 5 and change years, and had a really wonderful experience, learning the path of the entrepreneur and really honing my skills and understanding what it takes to start and scale a business, and then ultimately sell the business. So I found myself in 2018 wondering, what comes next, and had this crazy idea. What if we could take this harmful form of carbon that
Hmm.
is contributing to global warming, and remove it from the air in such a way that we could use it to produce diamonds. Diamonds are one of the most valuable and enduring forms of carbon known to man. Surely there's some type of chemistry we could use to employ to make this happen. And that was the initial thesis. So when we founded the company in 2018, that was the kind of underlying concept that we wanted to go and explore. And here we are. It's been 3 years just about, and we're now in production, getting ready to fulfill our first customer orders. We've been growing our wait list, which has been going really well, and reception from consumers has been fantastic. So in short, that's kind of my my Reader's Digest version of
Sure.
how I got to where I am today.
Were you studying sort of in 2018, were you deep diving into carbon capture and what was possible with it? Or was this something you had a friend circle that like just you guys started talking about it, or somebody tapped you on your shoulder and said, hey, you should look at this? Or was it just through your discovery that you realize that you could even do this, right? And I think it's important to explain like what are we actually doing here? You're telling me we could capture carbon and create diamonds, right? Like there's such a path there. Like how do you get to that point, right? Where you can take air and turn it into diamonds? Like, could you just take us through that crazy
Yeah.
process?
So, it all stems from a conversation my co-founder Dan and I were having. We worked together at David German way back when, built up a friendship that, lasted us over the past decade. And even though, our career paths had diverged, and he'd moved overseas, and, we stayed in touch. He was a buddy. And we got to a point where we were chatting over various startup ideas and catching up. He was living in Thailand. I was here, in the New York area, and it would be like 8 a.m. US or Eastern, I should say, and 8 p.m. in Bangkok. And we'd both be taking our dogs for a walk, catching up. And he'd wear face masks because the air pollution, in Bangkok was
Right.
considerable. And you can actually, like, if the conditions are bad enough, you get a sore throat just from breathing the air in at a long, and I've seen this myself, having spent some time in China, experienced that directly, where, a day of walking around, you feel like you just smoked a pack of cigarettes. And we get to talking about air pollution in general. And I'd been reading a book that focuses on all different types of decarbonization initiatives that are happening all over the world, and direct air capture. If you're familiar with, kind of the timing and the space and how things developed, it was like right around then, late 2017, early 2018, where direct air capture started getting a little bit more attention. Some of the first DAC plants were coming online. And as someone who's always been fascinated by material science, both professionally and personally, it was something that just grabbed my attention. And on a random call with Dan talking about air pollution, I said, wouldn't it be funny if we could turn CO2 into diamonds? I mean, that would be so cool. Talk about alchemy. And I think it was like a week later, we were catching up again, and the idea of making diamonds out of atmospheric CO2. I said, me neither. I've been thinking about it all week. And that's how we got started. I literally pulled out, I think I own every single textbook I ever bought for college. I couldn't justify selling those books back after what I
Right.
paid,
Oh,
knowing
it's
what
so
I would get
expensive.
for them. And
Insane.
my wife still gives me grief about it because I've got all of these engineering textbooks. She's like, you're never going to use them. And I proved her wrong, because I pulled out some old engineering textbooks from chemistry and material science classes that I'd taken, and really went as deep as I could go to put together a proposed process for what
Hmm.
this could look like. But I had no idea if it was going to work or not. It was a little bit too in depth for in certain areas. Like there was just things that I couldn't unpack to the degree that I wanted to without going down a much deeper rabbit hole. So I called my brother, who's a chemical engineer, and I said, "Hey, Jim, I want to pitch an idea by you. Tell me if this holds water. I don't want to spend any time or money on this unless I know that
Right.
there's something here." And he said, give me your information. I'll take a look at it. And called me up the next day. He's like, yeah, I mean, I think this could work, but you need to talk to my friend Anthony. And Anthony's a guy who I'd met also probably about a decade back. I remembered him being, super sharp, and my brother and him studied chemical engineering together. He loops me back in with Anthony, who I hadn't spoken to in a few years. And we get to talking, and he's like, oh, this sounds really interesting. I'm like, listen, I can't hire you, but we could maybe do some kind of nights and weekends consulting thing and
Hmm. Hmm.
take a little bit of time to vet this. I just, I want to get a professional opinion. And, I'm a mechanical engineer. I'm not a chemical engineer, but I have a pretty good handle on things. And he came back and said, yeah, I think this is going to work. And I'll quit my job today. This is amazing. I want to be a
Wow.
part of this. And he ended up becoming our third co-founder.
Wow.
So yeah, it's been interesting how that all, kind of unfolded. And it was a lot of it was just right place, right time, right people.
I want to try to draw a parallel here that I hope to make me understand it better, and hopefully maybe for some of the listeners to grapple with the idea a little better. So, in Cosars, we've covered a lot of companies that are taking plastic out the ocean, right?
Mhm.
The garbage of the ocean, so to speak, taking it out and creating products from it. Would you say that carbon capture is taking garbage from the air and then creating something out of it? Is there a parallel we can draw there from taking garbage out the ocean and creating products to taking garbage out the air, so to speak, quote unquote, and creating
Yeah,
products from it?
there's definitely a parallel,
Okay.
right? When I think of work that people are doing to, productize pollution in the ocean, much of that is plastic,
Hmm.
PET, high density polyethylene, and these are plastics that can be melted into new product.
Hmm.
That isn't as technically challenging or complex,
Right.
and, and,
Right. Because
and
it's already
requires
physical, right? It's kind of,
right. The
yeah.
the bigger challenge is actually going and finding the waste and collecting,
Correct.
enough volume of plastic waste from the ocean. For us, CO2 is everywhere,
Hmm.
right? So you don't have to go on a boat, go out into the ocean and try and collect the stuff. You don't have to pull it from coastlines. It's something that is everywhere. So, the broad, let me say this, the area where most companies are focusing on direct air capture is really just related to the air capture itself, pulling the CO2 from the air, not productizing it. In fact, the number one way that these companies are monetizing is actually by burying the CO2 in the ground. If you pump CO2 into the ground, it will actually chemically bond to certain rock formations and be locked underground forever.
Hmm.
So they monetize through the sale
Right.
of carbon credits.
Hmm. Hmm.
Now these are carbon sinks. These projects, they're sinking this carbon into the ground. Think like a heat sink, right? Heat
Hmm.
sink absorbs heat. You're permanently locking this carbon under the ground. This is not just like offsets against future emissions. This is actually tangibly driving an improvement by removing environmental carbon. The focus, for Ether and for some other companies that are out there, and we're not the only one by any measure,
Right.
but there are now groups that are coming in and saying, all right, now we can look at this as like a mining operation. We are mining the sky. We're taking this valuable element, carbon, and then we can productize it instead of just sticking it underground. There are companies working on fuels, for instance. There are companies that are working on some stuff I'm just not at liberty to talk about because I'm
Sure.
on NDA about stuff that
Yeah.
I'm
Yeah.
aware of.
Sure. Sure.
But we do see a lot happening in the fuels area. Opus 12, Prometheus. These are companies that are working on air to fuel
Hmm.
synthesis based on atmospheric carbon. It actually ties to some of the technology that we're utilizing in our tech stack. We're just doing it to a much more stringent degree of purity and composition of the hydrocarbon we are synthesizing from the air has to be very, very, very specific if we're going to use that to make diamonds.
The term lab grown diamonds has sort of been around for not a while, but I would say, what, 10 years, maybe something like that. It's kind of,
Commercially, yeah, I'd say probably around that 9 years, maybe.
yeah.
Since it's been out there, but the science is much older than that. The
Yep.
first diamond that was synthesized in a laboratory happened in 1954.
Wow.
It's an engineer working for GE, H. Tracy Hall, and I believe he got $10 for that breakthrough. And it's an unfortunate story as to
Yeah.
what happened with him, but he was essentially forced out of the company, and they went on to make how many countless dollars making diamonds for industrial purposes. And later on, about 30 years ago, a new methodology came to pass. It was a little bit more at the time. It was promising, but it was really underdeveloped. That process is called chemical vapor deposition, and it has since improved significantly. And now CVD is kind of the leading methodology for making high quality large diamonds. HPHT, which is the process that GE developed back in the 50s, is more well suited for growing smaller stones because HPHT stone, the rough diamond has more inclusions, more imperfections, and you end up cutting around that. And it's much easier just to get a larger volume of smaller stones.
And when we talk about lab grown, maybe go through what that actually is, right? Because it's kind of, I mean, obviously we come from historically, as a consumer, as just general people in the public. When we hear lab grown diamonds, like we hear grown, right? We think plants, right? We think, greenhouse, right? So like how does an actual diamond get grown, right? Like what does that even mean?
Yeah. So, essentially a diamond, as we all know it, and I'm not talking about simulants, and it's very important to distinguish between what is actually diamond material and what
Hmm.
is close to diamond material, like cubic zirconia, right?
Okay.
So cubic zirconia are, essentially it's a crystalline structure that doesn't have the same material properties, doesn't have the same optical properties, is an inferior material. You can use these for, sampling. You can use these for custom jewelry. They are not diamonds, and even the untrained eye can tell the difference.
Hmm.
Right. So I want to make sure that we're drawing a line in the sand. And when we talk about lab grown diamonds, we're not talking about simulants. We're talking about actual diamond material. These stones are chemically, atomically identical to what comes out of the ground, what was formed in the Earth's crust a couple billion years ago. But instead of taking a couple billion years to eventually be excavated from the ground and set into jewelry, they're grown in a laboratory, atom by atom, layer by layer, over the course of, call it, 3 or 4 weeks.
Unreal.
But similar to plants, if I've got a tomato that grows in a greenhouse versus a tomato that grows
Right.
out in a garden, it's
Right.
still a tomato. Right.
Right.
So I want to highlight the fact that what we grow and what is referred to as a lab grown diamond today are diamonds. The Federal Trade Commission has even said that these do not need to be called synthetic. These are, in fact, diamonds.
Yeah, it's fascinating. I want to also make a difference between the history of lab grown diamonds, like the current sort of options out there for lab grown diamonds is a bit different from ether diamonds, correct? As far as like, because they get it from extract from fossil fuels, is that correct?
Correct. So, I mean, that's the big differentiator here. And I'd say there's probably two, one that is universal and one that is, covers the vast majority of lab grown. So the first being the source of the carbon. We source every single atom of carbon for our diamonds from the atmosphere. So when you hold an ether diamond in your hand, that was nothing but air pollution a mere 12 weeks prior.
Well,
If we're talking about regular lab grown diamonds, they are sourcing their carbon from methane traditionally. And methane comes from oil drilling and fracking. So you can't, without considering, I mean, if you were to make a regular lab grown diamond and claim sustainability, you are negating the fact that there are scope 2 and scope 3 emissions related to the production of that raw material. And it's not something that can be utilized time and time again. So it's not a renewable resource. It is not a sustainable resource. It is if you're utilizing fossil fuel based carbon. So that's the big differentiator here. Everything that we do, we are trying to operate with radical transparency. We are trying to make sure that we're driving a real positive impact. And no matter what you're doing to maybe source clean power to produce your diamonds, if you're still doing it from fossil fuel carbon, it's not sustainable. So that's the big differentiator. And the second, as I just alluded to, is power. The vast majority of lab grown diamonds are grown with dirty power. When I say dirty power, I mean non-renewable power. So this happens predominantly in various parts of Asia, India, and China. And these are areas that are, not spending money on renewable power. They're maybe operating with coal-fired power plants, even natural gas, but regardless, there are emissions related to that power generation. So now, in addition to using fossil fuels to actually produce your diamond, you're also powering your manufacturing with fossil fuels. So there's this compounding effect, and these are both things that we're trying to address.
How could it be different? Like how is it different for you guys, right? Like from the power point of view, like how, like each one of those points, right? Like how is Ether trying to do those stages differently? Because that's probably equally as difficult as growing the diamonds. All these other steps are equally as difficult at scale.
Yeah, and it can be. It's getting better. And I think one of the unlocks that makes this the perfect time for a company like ours is the developments that we've seen with respect to renewable power, not only in terms of availability but cost. Solar
Hmm.
and wind have now
Hmm.
become competitive, right?
Yeah.
It's really interesting to kind of understand how that has changed and how fast it changed. When I talked about the why now for this company, even just 2 years ago, people gave me pushback.
Hmm.
Today, when I say, yeah, now we have the ability to tap into renewable power options and produce our goods using responsibly sourced electrons, it's now not even something that gives people reason to pause. So that change has been very recent, and ensuring that we're utilizing renewables through our supply chain is very important to us. So the goal long term, by say 2023, we actually expect to be a fully carbon negative company, so not just the product, but operations as well. We'd look to be generating our own power on site using renewable sources and potentially returning excess clean power to the grid.
Wow. Like you said, there's sort of CO2 everywhere, right? You can extract it from New York, right? Or Chicago or Beijing or Morocco, wherever. Is when you do that, is there a time that it can be stored to where its premier point? Is that a certain
It,
time once you capture it, you have to kind of go through start the process, or can you store it, have it as almost in air inventory, right? To where you're ready to go, you can then start the process of growing it.
Well, so there's a couple ways I can answer this. Storing carbon is very possible. We can
Hmm.
store it in a number of different ways. We don't necessarily want to store it as CO2.
Okay.
CO2, if we were to fill a big tank up with liquefied CO2,
Okay.
it has to evaporate,
Yeah.
right? Otherwise, pressure builds up as that vessel
Hmm.
warms, and we could get into a sticky situation.
Sure. Sure.
But if you convert that into your hydrocarbon, it can be stored long term. And frankly, I mean, we could just grow the rough diamond, and having rough diamond is the best way to store it. It's functionally inert. It's small. It's compressed. We can store it very easily, and then we can cut gemstones from it as needed. So realistically speaking, I don't know that we would ever look to store anything but the actual diamonds. But this is an ongoing manufacturing process, and we look to be inventory light so that you're getting as close to made to order as possible. Like we
Right.
won't hold. It's not like we just have the diamond and we have the jewelry, and when someone orders it, we cut the diamond, stick it in the jewelry, and ship it out. Everything is made from scratch. So when you
Yeah.
come to our website and buy an engagement ring, we're not pulling something off the shelf. That engagement ring it needs to be made for you. So we're putting a little bit of love into every piece.
That's crazy. So when we talk about actually capturing it, where are the? Is there just a lab? And then can you like you said, it's going to be way worse air quality in Thailand than it will be in like New York or Delaware, right? So do you have labs in places where there's bad air quality, or can you extract the CO2 from air in Thailand and then ship it to a lab or ship it to the ether lab to start the growing?
So, I mean, the short answer is yes, we could do that. The longer answer is there's not really a reason we would want to do that long term. If we can remove shipping
Right.
from our overall logistics, that's
Yep.
going to improve the net impact of the company. So we do want to vertically integrate. Right now, in our initial go to market, as we had to prove out this manufacturing technique and really get our tech stack operational, we had to do it in a disparate manner. So we actually have 3 different facilities that each handle one phase of production. We are going to be unifying them over the course of the next, call it year and a half under one roof. So by vertically integrating, not only does that enable us to have a tighter level of control over our net environmental impact, but and monitor every single aspect of production, but also just streamline things from an operational and logistics standpoint. So that is the goal. Right now, we're collecting our carbon. It happens on the roof of the Kiso power plant in Hinville, Switzerland, with our partner Climeworks. And
Ah,
we take that, and the actual diamond is grown here in the United States. So it's already happening in a fairly spread out manner today, but we are
mhm.
going to be consolidating. That's the path forward for the company.
When you talk to your old friends, maybe at David Yurman or other sort of, historically branded jewelry companies, do you see them a lot like we see every car company, right? Going to EV, right? It seems like in the matter of 36 months, every car company is going to be, electric by 2025, their full fleet of cars, right? Do you see that transformation happening where Ether is sort of the Tesla, where every single traditional jewelry company starts to do a similar process?
Yes and no. So there's definitely a trend moving in favor of sustainability, but you're not going to find luxury brands, right? So David Yurman's a luxury brand, right? This is not necessarily something that is going to be at every shopping mall. It's
Hmm.
it's different than some of the nationwide retailers you'll see advertised on TV. They're not going to use regular lab grown diamonds. There's a misalignment in consumer perception. Regular lab grown diamonds they don't have a special story. So Tesla did something different for the automotive industry because they were the poster child. They got the attention. They started driving that shift by changing consumer sentiment. We're not going to be able to do that with regular lab grown diamonds. However, I do see those brands coming to us and saying, hey, we'd like
Right,
to use
right.
your diamonds for our collections moving forward. Right now, we're focused on direct to consumer. We are
Hmm.
not in a position to go and supply these big heritage brands with all of the diamonds that they need for their production. But at some point in the future, we could be and hope to be. So, we would definitely compare to Tesla in terms of how we approach our consumer footprint long term. If Tesla was selling their electric motors to these
Right.
other car companies, that would be a better analogy. But I do think that there's an opportunity for us to grow a big wholesale footprint in the long term.
Yeah, that would be sort of the game changer if you could, it's kind of how you scale good in a way, is that
Exactly.
these big companies, just it's hard to transform into a sustainable company when you haven't been that way since your existence, right? It's
And
just hard to make that shift.
they won't do it unless it aligns with their other initiatives, whether that be,
Hmm.
just the way that they want to merchandise and position their line, their collections. We get to come in and introduce a really sexy story, something that really can grab people's attention and has a halo effect. It makes them look good for doing it, and hopefully works out in a number of different ways just at a business level.
Back in 2018, so far ago, when you were chatting with people and they kind of not scoffed at the idea, right, but just didn't take it too seriously. Have you talked to those people recently just about the transformation in those 2 years and sort of this moment of time where Ether is kind of like it's such a perfect timing in every aspect, from just the way sort of domestic policy is going and really global energy policy is going, and just the sustainability force around the world is sort of infecting business sectors everywhere, right? Which is amazing. Had those people come back to you and just be like, man, you called it and I totally missed the boat.
We were pretty good at staying in stealth and not really talking about this publicly. We did reach out. I mean, this is one of the benefits of having, co-founders that come from the industry, but we know the head of diamond buying at some of these big brands. We get to, call someone that we know, call someone whose 4th of July barbecue I've been to, multiple times, and be able to have those conversations with friends who also happen to be in the industry, and let them know. And whether it's because we had personal relationships or not, feedback even from those early days was, wow, if you guys could do this, you better let me know first. And as things have developed, we've continued to stay really hush hush and being kind of in stealth mode. We started really teasing out conversations with some big brands just because the sales process can be rather lengthy and we want to get in the door sooner rather than later. But the feedback from the industry since the very early days has been positive. And now I think, to your point, the timing is great. And
Hmm.
I think there was a little bit of like luck there, right?
Yeah,
We
sure.
saw certain trends moving. There's a little bit of prescience, a little bit of luck. It's a mix of the two. I can't say like we knew for sure that this was going to be timed out so well, but like I'll never forget in 2020 when the West Coast was basically on fire, and I had people calling me up saying like, as soon as we get through this whole COVID thing, climate's going to be right back at the forefront of conversation, and it could not have worked out better in our benefit. The fact that, I hate to say this, but like the problems we're having with our climate are becoming more apparent.
Hmm.
The destruction and the way that it impacts humanity is becoming more apparent, and that's only going to drive consumer sentiment. That's going to continue to support the trend line we've seen, where consumers, especially younger consumers, who, believe it or not, are the ones buying diamonds. Like 2/3 of all diamonds in
Hmm.
2019 that were sold were purchased by Gen Z and millennial consumers. So these younger consumers who are voting with their dollars are looking for brands that have alignment of personal value, right? Like if I wanted to buy a piece of diamond jewelry 5-10 years ago, sustainability might not have even been something that crossed my mind.
Right.
5-10 years from now, it's going to be a major consideration that goes into that purchase. So we do feel really well timed in how we've gone to market, and I think the reception from consumers and the press is generally supports that concept. And we've just been so excited that the world is into what we're doing.
I wanted to touch on a little bit more on climate change at the moment. You don't have to go in as much as you can, because I know you're not like a climate scientist, right? So some of these questions just they might not be relevant. But we're talking about sustainability. We're talking about sort of carbon capture. We touched on climate change. I guess, how does, for the layman like me out there, how does carbon capture affect climate change, right, in a positive way? Like how can people looking at that understand it in a way like elementary level, right? Like the less CO2 we have in the air is good for climate change, correct? At its simplest level.
Yeah, so I'll break it down for you. CO2 is, there are a number of different greenhouse gases, right? Methane, which I mentioned before, is actually worse for the environment by a significant degree, but it's a more volatile compound, so it breaks
Hmm.
down faster. So you emit CO2 into the air, it's going to last upwards of 100 years, right?
And
So
admitting, just real quick, at its base level, that is just from the amount of cars we have on the road, just the manufacturing process of products in general around the world, just all emit CO2.
yeah, I mean, there are a number of different major contributors that you need to look at it to understand kind of where it all comes from. Transportation, the transportation sector, it's not just cars, it's planes, it's trains that are
Sure.
require power, and if that power is not coming from sustainable sources, you have all of these different factors from the transportation sector. Buildings, inefficiency in buildings. I mean, I grew up in a house that was built in 1895. So it was really cool growing up in a really old house, but it was a really inefficient house, So you spend a bunch of energy heating that house through the winter, and that's just getting lost through drafty windows and areas of that structure that just are not well insulated. And actually, if you look into just like the footprint of buildings and energy inefficiency, that's rather significant as well.
Wow.
There are a number of different things, and we could really get into that, but it would be an entire conversation. What I would boil it down to is this: we're putting out a ton of carbon into our atmosphere every year over year. Even if we were to stop doing all of that, there's still all of that legacy carbon that's already
Mm,
in the atmosphere.
mm-hmm.
So direct air capture is really, really important, because no matter what we do to mitigate further emissions, we absolutely still need to remove some of that historical carbon that's already sitting in the air. So how can we do that? Well, we can plant trees. We can go and really not only plant new forests, but protect existing forests. So reforestation, afforestation, mangrove development, planting spec root, regenerative farming, right? So soil can actually capture carbon
Hmm.
if certain practices are in place, and
So not
soil
not
could.
outrageous things though, right? Like
The
the
natural climate solutions that are
yeah,
available to us today are plentiful, but there are
yeah.
challenges, right? If you plant a forest, as those trees grow, they're pulling carbon out of the air, right? Like the cellulose that makes up the tree, that's carbon based, right?
Mhm.
So they're literally turning air into wood. And if that forest burns down, all of that
Mm,
carbon goes right back into the air.
mm, mhm.
So where direct air capture comes into play, and why it's so important, is it helps augment the total capacity of drawdown potential for how much we can actually pull out of the air, because natural climate solutions are not going to be fast enough. We can't plant enough forests fast enough to prevent catastrophic climate change or the path that we're currently on. So we need these tech-enabled solutions to augment these natural climate solutions, and we need to do it in a way where it's not just capturing carbon, but sequestering it as well. So if I were to pull down atmospheric carbon and use it to make, CO2 for bottling beverages, right? Every time you buy a soft drink or a bottle of beer, it's got CO2 in it. CO2 is used to pressurize the lines at the tap when you're buying a pint at the bar. That CO2 is sourced traditionally through it's as a byproduct of a number of different industrial processes, none of which are environmentally friendly. So being able to kind of substitute that is great, but at the end of the day, the carbon still ends up back in the air. I drink a beer, I burp, that CO2 is going right back into the air. It finds its way back. So that's not a sequestration. Sequestration is when you pump it underground and it chemically binds to rock formations, or you turn it into a diamond. These are not the only two ways of sequestering carbon, but if it's permanent, then you can call it sequestration. Otherwise, it's carbon capture and utilization. And I think one of the biggest challenges with the space is all of the language, and it's so confusing. And people ask me all the time, what's the difference between a carbon credit and a carbon offset, and a carbon offset versus a carbon sink? And this is one of the challenges that will, as a society, solve as people become more educated over time. If you talked about climate change 10 years ago, everyone's like, what's climate change? I know what global warming is. And then we
Mhm.
realized that, weather and climate are two different things, and people are becoming more savvy around that. And that'll be something that kind of continues to evolve and will benefit humanity at large as people become a little bit more, tied into what the different meanings are. And, for us, it's really important that the carbon that gets pulled down be sequestered. And that's why diamond, I mean, you've heard the saying, a diamond is forever. And what I
Mhm.
love about that is it's true. You turn atmospheric carbon into a diamond, it's never going back into the air. And that's something that we're pretty excited about.
Couple more questions here before we end. One would be the direct air capture and the possibilities of that. Maybe just not in sort of the diamond sector, right? But maybe if you didn't start a diamond company, like what are some of the other things for maybe other aspiring entrepreneurs out there that they can look to and say, hey, direct air capture can not only create lab grown diamonds, but it can also create these other things maybe in other sectors that could have the same sort of sustainable impact.
Yeah, I mean, it's tough to say for a few reasons. I mean, there are different ideas that we'd like to pursue ourselves down the road. So,
Gotcha,
I
gotcha.
don't want to give up
Sure,
some of our ideas, but
sure, sure.
honestly, we put it this way: you are carbon based. I am carbon based. The computers that we're using to communicate right now are carbon based. If we're able to mine the sky for carbon, there are different ways that carbon can end up in products that we know and use and love. How we do that, how we do it responsibly, those are big questions that need to be answered, but there are ways to do it. And I think the proof is in the pudding. We've done this now. You can utilize technology to drive real impact. You can use business to do good. we incorporated as a public benefit corporation with the explicit goal of making sure that we are respecting our number one stakeholder, planet Earth, above all else. And really, it's super important to us that for every diamond we produce, there is a real tangible impact on the environment. And the same could be said for a number of different products that get introduced, whether those are raw materials for industrial use, for consumer consumption, or consumer goods. So, at the end of the day, I just encourage people who are interested to start paying attention. This is going to be the biggest area of wealth creation in our lifetime, right? This is going to be the biggest opportunity as climate comes to the forefront in all that we do. It's the number one underlying trend that I'm bullish on across anything happening on this planet. So, if you're interested in getting into the space, there are some great resources. I always tell people, check out the My Climate Journey podcast. Right. There's this fantastic podcast started by a guy named Jason Jacobs. I don't even know how many episodes he's into it now, but I started listening to it when I wanted to get into the climate space, as we started working on this project. And there's a fantastic Slack community now, and I've met so many fantastic people. On Deck has their climate fellowship, which I'm super excited to be
we just had them on a couple weeks ago.
Fantastic! Yeah. I just found out I was accepted into the fellowship, so I'm going to be.
It was so fun. I was going to mention that to you when we got off. I was like, you gotta go here and join that, because it's amazing people like you, really just doing some.
Can I ask who did you interview? Was it Candace by any chance?
We did Candace and Ty. Yeah, Ty, who does On Deck Scale. Yeah, and Candace.
Absolutely.
So
I met Candace through the My Climate Journey Slack community, and she obviously was espousing all the the benefits of the On Deck fellowship. Sure. And I said, I'm gonna throw my hat in the ring, and we're excited. I think it actually kicks off this weekend.
Yeah, no, congrats. It's going to be amazing. I'm bullish on them, on what they're doing. Well, so one last question. I'll sort of end on this, and I try to end on a little bit of the future. And I know that's tough sometimes, but I'd like to just get an idea of sort of long-term thought processes. And, from like we mentioned 5-10 years down the line, what does success look like, for you, whether it's, personally or from an Aether perspective? What are some of the successes that you would like to see, right, from the company or from you in general? Is it just tackling, climate and really using consumerism to do so, right? Or is it using technology to just innovate different sectors around the world around this sort of climate tech that's, like you said, it's going to be sort of the next wave of job creation and wealth creation. So what does the 5-10 years look like?
In our articles of incorporation, where we lay out the reason for our existence, we stipulate that it's not just about the development and commercialization of like sustainable manufacturing technologies that is core to it, but it's also, serving as an example to promote positive business practices, for companies all over the world that are looking to understand how can they be more responsible. We do want to be able to serve as that example, but our number one KPI ultimately comes down to how much carbon we're removing from the air. So, my goal over the next 5 years is to remove as much as we possibly can. We have some lofty goals long term. I would love to scale to such a degree that we could remove the entire carbon footprint of the diamond trade. That's not that crazy to think. It doesn't require a whole lot of deep market penetration to get to that point. And that excites the heck out of me, because, if we're offsetting the entire footprint of the industry, then we can start chipping away at the historical carbon that the diamond trade has pumped into the air over the last century. And that's something that, will have a lasting impact on the planet. And that's my ultimate goal. That's why I started the company, is leaving this planet a little better than it was when I arrived. And for me, kind of going beyond that, there's this one underlying trend that we know is going to persist over the next 5 to 10 years and even 20 years. The number of diamonds coming from the ground is actually reducing year over year. So when you open a new mining operation, what the mineral deposit looks like. You know how much kimberlite is there. You know how long you're going to be able to mine diamonds from the ground. And some of those mines are running up on their expiration date. The Diavik mine, I believe, is closing in 2025. It's located right next to a massive body of water. In 5 years, when they've stopped pulling crystal carbon from this mine, they're going to flood it with water, and it'll be left for the fishes. That is going to happen to 70% of all of the mines that are operational today by the year 2040. So the number of diamonds coming from the ground is going to cut in half over the next 20 years. But demand goes up every year. So that's going to do some wonky stuff to, supply demand. When demand goes up and supply goes down, drives prices up, which is only beneficial for anyone that's in the trade. And it means at a societal level, if human beings want to continue buying diamonds, we need to backfill. We need to have a new source for diamonds. So the future of lab grown is certain. And that's really what excites me. If we know that this future of the industry is moving in that direction, and we have this differentiated story, mapping that to how we want to achieve our goals on the decarbonization front is something that we can do with a high degree of confidence. And that's what excites me.
Wow. Love it, my man. Thank you so much for taking the time. I'm glad we could put this together because I've been, following from afar for a while. Glad to see it launch. Glad to see it, doing well within the first few months of being live. And I just can't wait to see the growth and just see the impact that it creates, not only just in the diamond sector, but I think can be an innovative approach to a lot of other sectors around the world. And I think that's what, inspires me about all this, is that it could always inspire and generate things we don't even think about, right? And people will think about ways to use this technology and this process to, create amazing things that will go on to impact the world in different ways, right? So appreciate the time.